This is Jim Green of JMR Systems. This movie vignette is going to show how to create coordinate systems on faces of a part and correctly orient the coordinate system to a 0 for that face. I'm opening a part that is on the subspindle, and I'm on the current turning plane and the work group that created the turning profile. So that's why I see on my part I see blue geometry. That means I'm on the right work group and I'm on a coordinate system. I usually go back to start from the original turning coordinate system, though it's not necessary. Now what we're going to use is a technique of face selection. So I have face select activated and I pick a face. And I want to create a new work group, and I'll call this work group Tooth 1. I want to create a new coordinate system, and I want that coordinate system to be aligned through the plane, which is the Alt selection here. Now I'm going to unzoom and verify that my spindle direction is pointing upward, which it is. I'll go back to previous view, and now I want to extract features from the solid, and I usually leave a tolerance of, say, 10 thousandths. I'm going to turn off the solid here for a minute to show you that the circles that came out here, I'll turn labels on, the circles are on a different coordinate system. And if I look down here and click on the other coordinate system, it created those on the main spindle. Well, I want the coordinate system to be associated with the subspindle. So what I'll do is just window in here and pick those 3 circles, and I'll go up to back to my subspindle. I'm on that, and I go modify, change coordinate systems XYZ. That now puts the geometry that was once on the main spindle on the subspindle. Now I'm going to delete that coordinate system from the main. Now I'm back to the subspindle. I have geometry on the Tooth 1. I want to call this Tooth 1 coordinate system so that I can remember which one's which. I need I'll use the center point of this circle, and we'll extract that like we normally would, to be my origin of this coordinate system. So by just pre-selecting and clicking on it, now you'll see that my origin of the coordinate system is there. If I turn my solid back on, there we are. So let's move over to Tooth 2. We can do the same thing here again. I go back to my ZX plane on the subspindle, select the face, new work group, let's call this Tooth 2, and I want to create a new coordinate system, align to it, and move to it. Unzoom to verify that I do have a positive Z spindle. I do. Previous view back, I want to extract geometry. 10 thousandths tolerance. I get the same situation here where the circles are on the main spindle. So I'll go back to the subspindle coordinate system, pre-select these circles, and move those to my subspindle coordinate system. Change CS XYZ. Delete the main spindle work group. And now I need the center point of this to become my coordinate system center point, pre-selected, and hit my coordinate system. Now what happened here, if I unzoom and turn on my solid, my 2 work groups that were created here were also moved. So at this point in time, what I would do is go back to these coordinate systems. Let's call this Tooth 2. Window back in there and just recreate that geometry. And you'll notice that what happens again, it wants to put those circles, in this case on the main spindle, because it does coordinate with the exact coordinate system for the YZ plane on the main spindle. And there again I would have to switch those around one way or the other to, if I needed the circle for drilling, or the point for drilling, I would take all the circles in here and put them back on the subspinal work group. Turn off my labels so I don't have those in the way. Put those back in on the tooth, modify, change coordinate systems. So let me previous view this, and you'll see now I have my toolpath, or the geometry ready for creating toolpath. That's it. Thank you, Jim Green.